Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. The Galileo paradox. Galileo Galilei, in his final work Discorsi e dimostrazioni matematiche, presented a paradox about infinite quantities that anticipates later discoveries in set theory and challenges intuitions about size and comparison. And the paradox concerns the relationship between the natural numbers and the perfect squares, and Galileo observed that every natural number has a unique perfect square, obtained by multiplying the number by itself. And conversely, every perfect square corresponds to a unique natural number, its square root. And so there is a one-to-one correspondence between the natural numbers and the perfect squares, suggesting that there are just as many perfect squares as natural numbers, and yet the perfect squares are a proper subset of the natural numbers. Most numbers are not perfect squares. 1 is a square, 2 is not. 3 is not. 4 is a square, 5 is not, and so on, with squares becoming increasingly sparse as numbers grow larger. And this suggests that there are fewer perfect squares than natural numbers. And so Galileo's paradox is that the perfect squares seem to be both equal in number to the natural numbers by virtue of the one-to-one correspondence, and fewer in number by virtue of being a proper subset. And these two conclusions contradict each other, or seem to, and Galileo concluded that the concepts of equal, greater, and less do not apply to infinite quantities, that infinity transcends these comparisons, that we cannot meaningfully say that one infinite collection is larger or smaller than another. The paradox remained unresolved for centuries until the development of set theory by Georg Cantor in the late 19th century, and Cantor provided a systematic way to compare infinite sets, defining two sets to have the same cardinality if there exists a one-to-one correspondence between them, a bijection that pairs each element of one set with a unique element of the other. And under this definition, the natural numbers and the perfect squares have the same cardinality. Both are countably infinite. Both can be enumerated in a sequence, and the fact that the perfect squares are a proper subset of the natural numbers does not imply that they have a smaller cardinality, because infinite sets can be placed in one-to-one correspondence with proper subsets of themselves. And this property, far from being a contradiction or paradox, is the defining characteristic of infinite sets, the feature that distinguishes them from finite sets where proper subsets always have strictly smaller cardinality. Cantor went further, showing that not all infinite sets have the same cardinality, that there is a hierarchy of infinities, that the set of real numbers is uncountably infinite, larger in a precise technical sense than the set of natural numbers. And this hierarchy extends infinitely upward, each level of infinity giving rise to larger infinities through power set constructions. And so, while Galileo's paradox shows that some infinite sets are equal in size despite one being a proper subset of the other, it does not follow that all infinite sets are equal, and the study of different sizes of infinity, of cardinal arithmetic, became a central part of set theory and mathematical logic. Galileo's paradox also raises philosophical questions about the nature of mathematical objects and the applicability of mathematics to the physical world, because if infinite sets have properties that violate finite intuitions, if the part can be equal to the whole when infinity is involved, then perhaps infinite quantities are not genuine quantities at all, but merely symbolic manipulations, mathematical fictions useful for certain purposes, but not corresponding to anything real. And this nominalist or instrumentalist view treats infinity as a convenient idealization rather than a description of actual totalities, and it sidesteps the paradox by denying that infinite collections exist, and so the paradox has no physical significance. It is merely an artifact of extending finite concepts beyond their proper domain. Others embrace the reality of infinite sets, arguing that mathematical objects exist independently of physical instantiation, that the natural numbers and the real numbers are abstract entities with determinate properties, and that Galileo's paradox reveals not a flaw in mathematics, but a truth about infinity, that infinite collections behave differently from finite collections, and that our intuitions, shaped by experience with finite quantities, must be revised when dealing with infinity. And this revision is not a retreat or a compromise, but an expansion of understanding, a recognition that reality, whether mathematical or physical, is richer and stranger than common sense suggests. The paradox also appears in physics and cosmology, in discussions of whether the universe is spatially infinite, whether it contains infinitely many galaxies, infinitely many stars, infinitely many particles, and if so, whether these infinities can be compared, whether one infinite quantity is larger than another, and whether operations like addition or subtraction are well defined for infinite quantities. And these questions do not have obvious answers. They depend on the mathematical framework used to describe the universe, on assumptions about the structure of space-time, and on whether infinite sets in mathematics correspond to infinite collections in reality. Galileo's paradox was one of the first systematic explorations of infinity, one of the first attempts to rigorously analyze what it means for a collection to be infinite, and it anticipated many of the insights that would later be formalized in set theory, and Galileo's conclusion that the usual comparisons of size do not apply to infinite quantities was both right and wrong. Wrong in that infinite sets can be compared, and some are larger than others, but right in that infinite sets do not obey the same rules as finite sets, that the part can be equal to the whole, that addition and subtraction of infinite quantities are not straightforward, and that intuition trained on finite examples is an unreliable guide. The numbers stretch to infinity, 1, 2, 3, 4, 5, and among them the perfect squares, 1, 4, 9, 16, 25, sparse but infinite, and the correspondence exists, each number paired with its square, each square paired with its root, and the two collections, one a subset of the other, are equal in cardinality, equal in size, and this equality, which seems to contradict the part being smaller than the whole, is not a contradiction, but a truth about infinity, a revelation that the infinite is qualitatively different from the finite, that the rules change when quantities are unbounded, and Galileo's paradox remains a landmark, the first clear formulation of the strange properties of infinite sets, the first hint that infinity would require new mathematics, new concepts, new ways of thinking about quantity and comparison, and the paradox endures, not as a problem to be solved, but as a lesson learned, a demonstration that infinity is not a large number, but a different kind of thing entirely, and that understanding it requires abandoning intuitions that serve us well in the finite realm, but mislead us when we venture into the infinite. The Grelling-Nelson paradox. Words can describe themselves or they cannot, and this seemingly innocent observation becomes a doorway into paradox when Kurt Grelling and Leonard Nelson posed a question in 1908 that has troubled philosophers of language ever since. Some words are autological, meaning they possess the property they describe. The word short is short. The word English is English. The word polysyllabic is polysyllabic. And these words refer to themselves in a way that feels consistent and unproblematic. Other words are heterological, meaning they do not possess the property they describe. The word long is not long. The word German is not German. The word monosyllabic is not monosyllabic. And again, this seems straightforward. A simple division between words that apply to themselves and words that do not. The paradox emerges when the question is asked, is the word heterological? Itself heterological? And the mind stumbles immediately into the same kind of self-referential trap that haunts the liar paradox and Russell's paradox. If heterological is heterological, then it does not describe itself, which means it must be autological. But if it is autological, then it does describe itself, which means it must be heterological. And the loop spins without resolution, each answer immediately negating itself. This is not merely a trick of language, but a genuine problem for anyone attempting to build a theory of meaning or reference, because it suggests that not all predicates can be safely applied to themselves, that self-reference introduces instability into linguistic systems. Some philosophers argue that heterological is simply a defective predicate, a word that fails to have a coherent meaning because its definition leads to contradiction. Much like dividing by zero produces an undefined result in mathematics. Others suggest that the paradox reveals the difference between the use of a word and its mention, that when we ask whether heterological is heterological, we are confusing the word as an object with the word as a concept, and this confusion generates the paradox. Alfred Tarski proposed that language operates on different levels, with a meta-language used to talk about an object language, and that paradoxes like Grelling-Nelson arise when these levels are improperly mixed, when language tries to fully describe itself from within rather than from a higher vantage point. The paradox also connects to broader issues in semantics and the philosophy of language, questions about how words acquire meaning, whether meaning is fixed or context-dependent, and what it means for a word to refer to itself. If even simple adjectives can generate contradictions through self-reference, then the project of creating a complete and consistent theory of language may be impossible, or at least far more complicated than it first appears. The Grelling-Nelson paradox lingers at the edges of linguistic theory, a small question with large implications, a reminder that words are not just labels for things, but slippery tools that can twist back on themselves in unexpected ways, and that the quest to understand meaning must navigate carefully around the traps that self-reference sets. The infinite shadow paradox, when your shadow could cover the universe. Imagine standing in a bright room with a light source behind you, casting your shadow on the wall in front of you, and the shadow is roughly your size, perhaps slightly larger, depending on the distance between you and the light. And now imagine moving the light farther and farther away, keeping it directly behind you. And as the light moves back, your shadow grows larger, stretching taller and wider on the wall, because the light rays diverge more gradually, creating a bigger shadow. And if you continue this process, moving the light farther and farther away, your shadow continues to grow. And now the question emerges, what happens if the light source is infinitely far away? If the light comes from an infinite distance, does your shadow become infinitely large? Does it stretch across the entire wall, the entire room, the entire planet, the entire universe? And if so, what does this mean? How can your finite body cast an infinite shadow? And this is the infinite shadow paradox, a thought experiment that reveals tensions between geometry, infinity, and the behavior of light. Consider the geometry more carefully. When the light is close behind you, the light rays that graze the top of your head and the light rays that graze your feet diverge at a large angle, creating a shadow that is only slightly larger than your body. But as the light moves farther away, the angle between these rays decreases. The rays become more nearly parallel, and the shadow grows proportionally. And in the limiting case where the light is infinitely far away, the rays become perfectly parallel, and the shadow, if it still makes sense to talk about a shadow, is no longer a finite shape on a surface, but an infinite column of darkness extending forever in the direction away from the light. And your body blocks a certain solid angle of light, a cone of rays, and when the light is infinitely far away, this cone becomes a cylinder, extending infinitely. And so, In some sense, your shadow has become infinite. It covers an infinite region of space. But there is something strange about this conclusion, because in reality, when light comes from very far away, like sunlight which travels from the sun 93 million miles distant, shadows are sharp and well-defined, not infinite. And the reason is that even though the sun is very far away, it is not infinitely far. And more importantly, the sun is not a point source. It is an extended object, a sphere, and light comes from every point on the sun's surface. And these different light sources create slightly different shadows that overlap. And the overlapping softens the edges and prevents the shadow from extending infinitely. And so the paradox relies on an idealization, a perfectly point-like light source at infinite distance. And this idealization does not correspond to physical reality. And so the infinite shadow is a feature of the idealized model rather than a genuine physical phenomenon. Another way to resolve the paradox is to recognize that the concept of a shadow depends on there being a surface on which the shadow is cast, a wall or a floor or the ground. And if the light is infinitely far away and there is no surface, then there is no shadow in the usual sense. There is a region of space from which light is blocked, but without a surface to project onto. The notion of shadow loses its meaning, and so the infinite shadow is not a shadow at all, but an abstract geometric construction, a cylinder of blocked light extending through space. And whether this deserves to be called a shadow or an infinitely large shadow is a matter of definition rather than a physical fact. The paradox also connects to questions about parallel lines and perspective, because in ordinary experience, parallel lines appear to converge at a vanishing point on the horizon. Train tracks appear to meet in the distance, even though they remain the same distance apart. And this convergence is a feature of perspective, of how our eyes or cameras project three-dimensional space onto two-dimensional images. But in the case of light rays coming from infinity, the rays are truly parallel, not merely appearing parallel, and parallel lines by definition never meet, extend forever without intersecting. And so the shadow, defined as the region blocked by your body from these parallel rays, is a cylinder that extends infinitely. And there is no convergence, no finite boundary. And the paradox is that this seems to make your small body relevant to arbitrarily distant regions of space, seems to give your finite physical presence infinite geometric reach. Some philosophers have used the infinite shadow paradox to argue about the nature of infinity and the limits of physical realizability, suggesting that infinite quantities like infinite distance or infinite extension cannot actually occur in the physical universe, that they are useful mathematical idealizations, but not genuine features of reality. And the paradox supports this view by showing that infinite idealizations lead to strange consequences that do not match experience. And so perhaps infinity is a tool for calculation rather than a description of the actual world. And the paradox is avoided by rejecting the premise that light can come from infinite distance, or that shadows can extend infinitely. Others embrace the paradox as revealing something genuine about geometry and light, accepting that in an idealized geometric setting, with a point source at infinity and parallel rays, shadows do become infinite. And this is not a contradiction, but a feature of how geometry works, and the fact that physical light sources are extended and finite distances are never truly infinite means that the paradox does not apply to real shadows, but it remains a valid thought experiment about what would happen in an idealized limit. And such thought experiments are valuable for understanding the structure of space and the behavior of light, even if they do not correspond to observable phenomena. Visualize yourself standing on an infinite flat plane, with a point of light infinitely far behind you, and the light rays come in perfectly parallel, and your body blocks a cylinder of these rays, and the cylinder extends forward forever. And if there were a wall anywhere in front of you, no matter how far away, your shadow would appear on that wall, and the shadow would be exactly your size, exactly your shape, because the parallel rays preserve size and shape. And so, in this sense, your shadow is not infinitely large, but infinitely long. It is a finite cross-section extended through infinite space. And whether this counts as an infinite shadow or merely an infinitely extended shadow is a question of terminology. But the strangeness remains, the fact that your finite body has infinite geometric influence. The paradox also appears in discussions of cosmology and the nature of the universe, because if the universe is infinite in spatial extent and light travels in straight lines, then in principle, a light source on one side of the universe could cast shadows of objects on the other side, and the time required for light to travel such distances would be infinite. And so the shadow would never actually form, would always be in the process of propagating, and this raises questions about whether infinite distances are meaningful, whether light travelling forever without reaching a destination is different from light that does not exist, and whether geometric constructions that invoke infinity are useful descriptions or merely mathematical artifacts. The shadow stretches forward, grows as the light recedes, and in the limit becomes infinite, a column of darkness extending without end, and you stand there, finite and small, casting a shadow that reaches to infinity. And the paradox asks whether this makes sense, whether infinite shadows are possible, whether geometry allows such things. And the answer depends on what idealizations are accepted, on whether point sources and infinite distances and perfect parallel rays are admitted. And if they are, then the shadow is infinite, and if they are not, then the paradox dissolves. And the paradox remains a teaching tool, an illustration of how infinity changes things, how limits can produce strange results, how geometric reasoning applied to idealized cases can lead to conclusions that violate intuition, and the shadow persists, stretching toward infinity, a monument to the strangeness of geometric idealizations and the care required when reasoning about the infinite. The is-ought problem: why facts cannot tell us what to do. Science describes the world, tells us what is, what exists, how things work, the laws of nature, the facts about atoms and organisms and stars, and these descriptions are supported by evidence, by observation and experiment, and they are objective, true or false, regardless of what anyone thinks or wants. And ethics prescribes action, tells us what ought to be, what we should do, what goals to pursue, how to treat others, and these prescriptions are normative, involve value and obligation. And the question that has haunted philosophy since David Hume raised it in 1739 is whether we can derive ought from is, whether we can move from factual premises to moral conclusions, whether what exists tells us anything about what should exist. And Hume's answer was no. There is a gap, an unbridgeable chasm between descriptions and prescriptions, between facts and values, between is and ought, and no amount of purely factual information can tell us what we should do. And this is the is-ought problem, sometimes called Hume's guillotine, because it cuts moral reasoning off from empirical inquiry, separates facts from values, and leaves us wondering how moral knowledge is possible if it cannot be derived from facts about the world. Hume observed that writers on morality begin with ordinary observations, with statements about human nature or God or social arrangements, statements that use the copula is, describing what exists, and then suddenly they switch to statements using ought or ought not, prescribing actions or condemning behaviours. And this transition, Hume says, is never explained, is never justified. The writers seem to assume that the ought follows from the is, that because things are a certain way we should act in a certain way, but this assumption is invalid. The ought does not follow. There is a logical gap, and any argument that moves from is to ought is either invalid or contains a hidden normative premise that was smuggled in. And if all moral arguments ultimately rest on normative premises that cannot be derived from facts, then moral reasoning is fundamentally different from empirical reasoning, is based on values or sentiments, or intuitions that are not themselves factual claims. Visualize an argument that tries to derive ought from is. Suppose someone says humans are naturally cooperative. This is a factual claim about human psychology, and then concludes, therefore, we ought to cooperate, a normative claim about how we should behave. And Hume's challenge is to explain how the conclusion follows from the premise, what licenses the move from description to prescription, and the argument seems to assume that what is natural is good, that we should act in accordance with our nature. But this assumption is itself a normative claim, a hidden ought premise, and if we make it explicit, the argument becomes humans are naturally cooperative, and we ought to act according to our nature. Therefore we ought to cooperate. And now the argument is valid, but it rests on a normative premise, the claim that we ought to act according to our nature. And this premise cannot be derived from facts about what human nature is. It is a value judgment, an ought claim, and so the original argument either was invalid or contained a hidden normative premise. And either way, the is-ought gap remains. The ought was not derived purely from is. The same problem arises for any attempt to ground morality in facts. If someone says actions that maximize happiness are good because happiness is what everyone wants, the argument moves from the fact that people desire happiness to the normative claim that happiness is good, and this move assumes that what people desire is good. Another hidden normative premise, or if someone says we should obey God's commands because God created us, the argument moves from the fact of creation to the obligation to obey, and this assumes that we ought to obey our Creator. Another normative premise, and in every case the derivation fails unless a normative premise is included, and if normative premises cannot themselves be derived from facts, then the ultimate foundation of ethics is non-factual, is based on values or intuitions or conventions that are not grounded in empirical reality. The is-ought problem creates a dilemma for moral philosophy. Either accept that moral claims are not factual, are not true or false in the way scientific claims are, but express attitudes or prescribe actions or reflect cultural conventions, and this leads to non-cognitivism or relativism, views that deny objective moral truth, or accept that moral claims are factual, but insist that moral facts are sui generis, are not reducible to natural facts, are known through intuition or reason rather than through empirical observation, and this leads to non-naturalism, the view that morality is objective but not part of the natural world, studied by science, or find some way to bridge the is-ought gap, to derive ought from is, and this requires showing that certain facts entail normative conclusions, that the gap is not as wide as Hume thought, and various philosophers have attempted this, have proposed that the gap can be crossed under certain conditions. One attempt to bridge the gap involves institutional facts, facts about social practices and their constitutive rules. John Searle argued that if you accept a role within an institution, you accept the obligations that come with it. If you are a chess player, you ought to move the bishop diagonally, not because of an additional normative premise, but because that is what it means to be playing chess. The ought is built into the description of the institution, and similarly, if you make a promise, you create an obligation. You ought to keep the promise, and this ought follows from the fact of promising, from the institution of promising and its rules, and Searle claims this shows that ought can be derived from is, that institutional facts bridge the gap. But critics respond that this only works if you already accept the institution, already grant that you ought to follow its rules, and so the normative premise is still there, hidden in the acceptance of the institution. Another attempt involves functional facts. Facts about what things are for. Philippa Foot and others argue that living things have natural functions. Hearts are for pumping blood, eyes are for seeing, and organisms can be evaluated by how well they fulfill their functions. A good heart pumps blood efficiently, a defective heart does not, and humans have functions too, and virtues are traits that enable humans to flourish, to live well, and so we ought to develop virtues, and This ought to follows from facts about human nature and human flourishing, but critics respond that this assumes flourishing is good, assumes that we ought to pursue the goals set by our nature, and these assumptions are normative, are not themselves derived from facts about what human nature is, and so the gap remains. Visualize the gap as a chasm. On one side stand all the facts, all the truths about how the world is, what exists, how things behave, and on the other side stand all the norms, all the truths about what ought to be, what we should do, what goals are worth pursuing. And Hume's claim is that no bridge connects the two sides, that you cannot start with facts alone and reach the norms, that any path from one side to the other requires a leap, requires introducing a normative premise that is not itself factual, and this chasm separates science from ethics, separates empirical inquiry from moral philosophy, and raises the question of how we can have moral knowledge if morality is not grounded in facts. The is-ought problem has implications for moral realism, for the claim that moral truths exist objectively, because if moral truths cannot be derived from natural facts, then what are they? How do we know them? And moral realists divide into naturalists who deny the gap and claim that moral facts are natural facts, and non-naturalists who accept the gap and claim that moral facts are sui generis, are known through intuition or reason, and both positions face challenges. Naturalists must explain how to bridge the gap, must show how ought follows from is, and non-naturalists must explain how we perceive non-natural moral facts, how these facts relate to natural facts, and whether morality can play any causal or explanatory role if it is separate from nature. The problem also affects applied ethics, because if we cannot derive ought from is then scientific information, alone cannot tell us what to do, cannot settle moral questions. A doctor knowing all the medical facts about a patient still needs normative principles to decide whether to continue treatment or allow death. An economist knowing all the facts about wealth distribution still needs values to decide whether inequality is unjust. And science can inform these decisions, can tell us the consequences of different actions, but it cannot by itself tell us what we ought to do, what outcomes we ought to pursue. And this means ethics is ineliminable, is not reducible to any empirical science, requires normative reflection and judgment that goes beyond factual knowledge. The chasm yawns, facts on one side, values on the other, and no bridge appears and Hume's guillotine falls. Severing is from ought, description from prescription, and the is-ought problem remains, unsolved, persistent, dividing metaethics into camps, challenging moral realism, questioning whether science can answer moral questions, and forcing recognition that normativity is distinct, that ought is not reducible to is, that values are not facts, or if they are facts, they are strange facts, facts that cannot be derived from ordinary empirical observations, and the problem endures as one of the central puzzles in philosophy, a reminder that ethics is autonomous, that moral reasoning requires more than empirical knowledge, and that the relationship between what is and what ought to be remains one of the deepest and most difficult questions we face. The liberal paradox, when freedom and choice destroy each other. An economist named Amartya Sen constructs a paradox about individual liberty and social choice, about whether societies can simultaneously respect individual freedom and satisfy basic welfare criteria. And the paradox goes as follows. Suppose society values individual freedom, values the principle that each person should be decisive over certain personal matters, should have sovereignty over a domain of choices, perhaps what to wear or what to read or how to live, and call this principle minimal liberalism, the requirement that each individual has at least one pair of alternatives where their preference determines social choice. And now suppose society also values Pareto efficiency, values the principle that if everyone prefers outcome A to outcome B, then society should choose A, should not choose an outcome that makes everyone worse off. And Sen proves that these two principles are incompatible, that no social decision procedure can guarantee both minimal liberalism and Pareto efficiency, that respecting individual freedom can conflict with respecting unanimous preferences. And this is the liberal paradox, also called the impossibility of a Paretian liberal, a demonstration that liberal values contain internal tensions, that freedom and welfare can conflict, that respecting individual choice over personal matters can lead to outcomes that everyone prefers to avoid. And the paradox has generated enormous literature, has sparked debates about the nature of rights, about whether rights are absolute or can be traded, about how to resolve conflicts between liberty and welfare, and the liberal paradox remains one of the most important results in social choice theory, remains a challenge to liberal political philosophy. Imagine a specific example. Two people, call them Prude and Lude, and a book, and Prude prefers that no one read the book, finds it offensive, would be most satisfied if neither reads it. And second best for Prude is if Prude reads it rather than Lude reading it, because at least then Prude can argue against it from first-hand knowledge, and worst for Prude is if Lude reads it while Prude does not. And Lude has opposite preferences, most prefers that Prude read the book, because Lude thinks Prude needs liberalising. Second best for Lude is that Lude reads it, and worst is that neither reads it. And now apply minimal liberalism. Say that Prude should be decisive over whether Prude reads the book, should have the right to choose for themselves, and Lude should be decisive over whether Lude reads the book, and Prude chooses not to read, exercises their right, and Lude chooses to read, exercises their right, and the outcome is Prude does not read and Lude reads, but both prefer the outcome where Prude reads and Lude does not. Both rank that outcome higher, and so the liberal outcome, the outcome that respects individual rights, violates Pareto efficiency, produces an outcome that both prefer to avoid, and the paradox emerges, respecting rights produces an outcome that unanimous preferences reject. The liberal paradox demonstrates that rights and welfare can conflict, that giving individuals control over personal matters can lead to collectively worse outcomes. And this challenges the assumption that liberalism is coherent, that respecting freedom always improves welfare, and Sen's paradox shows that this is false, shows that freedom and welfare can diverge, that societies face trade-offs between respecting rights and respecting preferences, and different resolutions prioritize differently. Some prioritize rights and accept that Pareto improvements may be blocked, accept that unanimous preferences may be overridden by individual sovereignty, and other resolutions prioritize welfare and accept that rights may be violated when everyone would benefit, and neither resolution is fully satisfying. Both involve accepting tensions within liberal values. Visualize the paradox as revealing a cycle. Individual rights produce an outcome, unanimous preferences reject that outcome and prefer an alternative. But that alternative violates individual rights, and we are stuck cannot satisfy both rights and preferences simultaneously. And this cycle shows that liberalism contains contradictions, that its commitments can conflict, and resolving the conflict requires prioritizing, requires deciding whether rights or welfare is more fundamental, and different liberal theories answer differently. Rights-based liberalism prioritizes rights and accepts welfare losses. Welfare-based liberalism prioritizes welfare and accepts rights violations, and no theory satisfies both perfectly. One response to the liberal paradox argues that the problem is with the specification of rights, that the rights in Sen's example are meddlesome, are concerned with what others do, and proper rights are self-regarding, are concerned only with what you do, not with what others do. And if rights are limited to self-regarding matters, then the paradox may not arise, then respecting rights may be compatible with Pareto efficiency. And this response requires distinguishing between self-regarding and other regarding preferences, between preferences about your own life and preferences about others' lives. And liberalism protects the former, but not the latter, and this resolves the paradox by restricting the domain of rights, by denying that Prude has a right to prevent Lude from reading, even if Prude prefers that outcome. Another response accepts the paradox, accepts that rights sometimes block Pareto improvements, and argues that this is acceptable, that rights are constraints on social choice, are not mere preferences to be aggregated, but are protections that cannot be violated, even for welfare gains. And this deontological response treats rights as absolute, as trumps over welfare, and accepts that respecting rights may produce outcomes that everyone prefers to avoid. And this response is consistent with rights-based liberalism, with the view that individual freedom is foundational, is not negotiable, and welfare considerations cannot override rights. And the paradox is accepted as showing the cost of rights, showing that freedom has trade-offs. A third response questions the Pareto principle, argues that unanimous preferences should not always be respected, that preference satisfaction is not always good. And in Sen's example, the preferences are meddlesome, are concerned with interfering in others' choices, and perhaps such preferences should not count, should not be given weight in social choice. And this response modifies the Pareto principle to exclude meddlesome preferences, to respect only preferences about self-regarding matters. And this resolves the paradox by restricting the domain of preferences that matter for social choice. And this approach has some support, has intuitive appeal, because it seems wrong to let people's preferences about others' private behaviour determine social outcomes, seems to give too much weight to intolerance or judgment. The liberal paradox also connects to debates about paternalism, about whether societies should prevent people from making choices that harm themselves, and paternalism violates minimal liberalism, overrides individual choice for welfare reasons, and the paradox shows why such overriding might be tempting, shows that respecting choice can produce outcomes that the chooser prefers to avoid. And this creates pressure toward paternalism, toward intervention, but liberalism resists, maintains that individual choice must be respected even when it leads to regret. And the tension between respecting choice and promoting welfare is permanent, is built into liberal theory, and the paradox makes it explicit. Some argue that the liberal paradox is merely theoretical, is unlikely in practice, requires specific preference structures that rarely occur, and empirical investigation of whether such structures exist would be valuable, but regardless of frequency, the paradox is important as a logical possibility, as a demonstration that liberal principles can conflict. And this shows that liberalism requires trade-offs, requires balancing competing values, and political philosophy must grapple with these trade-offs rather than assuming that liberal values are always compatible. The paradox also raises questions about whether societies should recognize rights at all, whether individual sovereignty over personal matters is justified if it can lead to collectively worse outcomes. And consequentialists might use the paradox to argue against rights, to argue that social choice should be based on welfare alone, without constraints from individual rights. But most find this conclusion extreme, find that rights are valuable despite potential conflicts with welfare, and the challenge is to specify rights carefully, to balance rights and welfare, to create institutions that respect both as much as possible while recognizing that perfect compatibility is impossible. Prude and Lude exercise their rights, make their choices, and the outcome satisfies liberal principles but violates Pareto efficiency, and both prefer an alternative, but that alternative requires violating someone's rights, requires overriding someone's choice, and the paradox stands unresolved, showing that liberalism contains tensions, that freedom and welfare can conflict, that rights and preferences can diverge, and the liberal paradox endures as one of the important impossibility results in social choice theory, as a challenge to liberal political philosophy, as a demonstration that liberal values are not perfectly compatible. And the paradox remains a permanent feature of liberal theory, requiring careful navigation, requiring trade-offs between competing values, and showing that coherent liberalism is more complex than it appears. The McGurk effect. Why seeing changes what you hear. A person watches a video of someone speaking, sees their lips move, hears sounds, and perceives speech, but something strange occurs. The auditory signal says one thing, the syllable baha, and the visual signal shows lips making a different movement, the movement for ga, and yet what the person hears is neither ba nor ga, but da, a fusion of the two inputs, a compromise between hearing and vision. And this is the McGurk effect, discovered by psychologist Harry McGurk in 1976, a robust illusion showing that speech perception is multimodal, integrates auditory and visual information, and vision can alter what you hear, can change the perceived phoneme, even though the auditory input remains constant and the effect is automatic, is unconscious, occurs even when you know it is happening, and closing your eyes restores the original bar sound, showing that vision was modifying auditory perception, and the McGurk effect reveals that perception is not modality specific, but is multimodal, that different senses interact, that seeing influences hearing and hearing influences seeing, and perception is a unified process that integrates information from multiple sources. And this has implications for theories of perception, for understanding consciousness, and for recognizing that sensory modalities are not separate channels, but are interconnected systems that jointly construct perceptual experience. Imagine experiencing the effect, watching a video where someone's lips move saying ga while the audio plays ba, and you hear da, not what was said, not what the lips showed, but a fusion, and you know the audio is ba, can check by closing your eyes, but when your eyes are open you hear da, vision overrides audition, changes what you hear, and the effect is involuntary, is not something you can turn off. Perception integrates the inputs automatically, and this integration occurs before consciousness, before you become aware of the sound, and what reaches awareness is already a fusion, already combines hearing and seeing, and you cannot access the separate inputs, cannot hear bay and see gay separately, but only experience the integrated da. The McGurk effect demonstrates that speech perception is not purely auditory, not simply a matter of processing sound waves, but involves visual information about lip movements, facial gestures, speaker identity, and context. And the brain combines these sources, weighs them according to reliability, and produces a unified percept. And when visual and auditory information conflict, the brain compromises, produces a perception that splits the difference. And this compromise shows that perception is not just input-driven but is constructed, is the result of unconscious inference, of combining cues according to probabilities. And McGurk is an example where the inference goes wrong, produces a percept that does not match either input perfectly, but represents the brain's best guess given conflicting information. Visualize the perceptual system as Bayesian, as computing probabilities based on sensory inputs and prior expectations. And when you see lips saying gya and hear br, the brain computes that die is most likely given that visual and auditory cues are both somewhat unreliable and the percept should compromise between them. And this Bayesian integration explains many perceptual phenomena, explains how the brain combines cues from different senses, weights them by reliability, and produces unified, coherent experience. And the McGurk effect is a case where the integration produces an incorrect result, but reveals the normal processing that usually works well, that usually integrates senses accurately. The McGurk effect challenges theories that treat senses as separate, that analyze vision separately from audition, that assume perception is modality specific, and the effect shows that modalities interact. That perception is fundamentally multimodal, and this has led to theories of multisensory integration, to research on how the brain combines information from different senses, where in the brain this integration occurs, and what rules govern it. And the McGurk effect has become a paradigm case, a standard demonstration of multimodal perception used in countless psychology classes and research studies. The effect also has implications for understanding consciousness, because the fusion occurs before consciousness, occurs in processing that we do not have access to, and what we experience as the result of this processing is the fused percept, and we do not experience the separate auditory and visual inputs, do not have access to the processing that combined them, and consciousness receives only the output, only the unified percept, and this shows that much of perception is unconscious, is hidden from awareness, and conscious experience is constructed from unconscious processing, and the construction is so seamless that we do not notice it, do not realize that our experience is a synthesis rather than a direct recording of input. The McGurk effect appears in discussions of cognitive penetrability, because if perception is modular, if sensory systems are encapsulated, then one modality should not influence another. Vision should not alter what you hear, but the McGurk effect shows cross-modal influence, shows that perception is not strictly modular, that different sensory modules communicate and interact. And this qualifies strong modularity, suggests that while early sensory processing may be modular, later perceptual processing integrates across modalities, and perception as a whole is not modular but is interactive. And the McGurk effect is evidence for this interactivity, for perceptual systems that are not strictly separated but are interconnected. The effect also has practical implications for understanding speech perception in noisy environments, for designing hearing aids that take advantage of visual information, for developing virtual reality systems that create convincing multimodal experiences, and for understanding how perception can be manipulated, how illusions can be created through conflicting sensory cues. And the McGurk effect shows that perception is vulnerable to these manipulations, is not simply determined by physical input, but depends on how inputs are integrated. The person watches the video, hears da, knows the audio says ba, sees the lips say ga, and yet perceives da, a fusion that is none of the inputs but is the brain's compromise. And the McGurk effect persists, demonstrates multimodal integration, challenges modular theories, reveals unconscious perceptual processing, and stands as one of the most famous demonstrations in cognitive psychology. A simple effect that reveals deep truths about how perception works, how senses interact, how consciousness is constructed from unconscious processes, and the effect remains robust and automatic, a permanent feature of human speech perception, showing that seeing changes, hearing, that perception is unified, that the brain constructs experience from multiple sources, and the fusion continues. Da heard when ba was spoken, and ga was seen, and the McGurk effect endures. The ontological paradox, why existence itself is impossible. A philosopher asks the most fundamental question in metaphysics, asks why anything exists at all, why there is something rather than nothing, and this question seems to demand an answer. Seems like there must be some explanation for the existence of the universe, some reason why being triumphs over non-being, and yet every proposed answer creates problems, creates paradoxes, leads to infinite regress or unjustified stopping points. And this is the ontological paradox, the puzzle about existence itself, about whether existence requires explanation, whether existence can be explained, whether there could be a sufficient reason for there being something rather than nothing. And the paradox arises because existence seems to be a brute fact, seems to be something that just is without explanation, and yet accepting brute facts seems unsatisfying, seems to violate the principle of sufficient reason, the principle that everything has an explanation, and this tension between the demand for explanation and the impossibility of ultimate explanation creates the ontological paradox, a paradox that has troubled philosophers since ancient times, that remains unresolved, that perhaps cannot be resolved, and that reveals deep limits on human understanding, on our capacity to explain why things are rather than why they are not. Imagine trying to explain why the universe exists, why there is something rather than nothing, and you might say the universe exists because it was created, but then you must explain why the creator exists. And if you say the creator exists necessarily, exists by its own nature, cannot fail to exist, then you face the question of why necessary existence is possible, why there are any necessary beings, why the category of necessary existence is not empty. And if you say the creator has no explanation, exists as a brute fact, then you have abandoned the demand for explanation, have accepted that existence requires no reason. And if existence requires no reason, then why not say the universe itself exists as a brute fact? Why invoke a creator at all? And the explanatory chain either goes on forever, infinite regress, or stops at something unexplained. Brute fact, and neither option is satisfying. Neither provides the ultimate explanation we were seeking. And the ontological paradox emerges, the recognition that existence cannot be fully explained. That the question why something, rather than nothing, has no satisfactory answer. The paradox can be stated as an impossibility argument. Either everything has an explanation, or some things are brute facts without explanation. If everything has an explanation, then there must be an explanation for the totality of all facts, for why anything exists at all. And this explanation must appeal to something outside the totality, something that explains why the totality exists. But nothing is outside the totality. The totality includes everything. And so there can be no explanation for the totality. And so not everything has an explanation. And there are brute facts. And if there are brute facts, then the principle of sufficient reason is false. And we must accept that some things exist without reason, without explanation. And if existence requires no explanation, then the question why something rather than nothing has no answer is not a real question, is based on the false assumption that existence requires explanation. Visualize nothingness, absolute nothingness, no matter, no energy, no space, no time, no laws of nature, no mathematical structures, no abstract objects, nothing at all. And from this nothingness, something emerges. The universe comes into being. And the question is why? What caused this emergence? What explained this transition from nothing to something? And the problem is that causes and explanations presuppose existence, presuppose that there are things that can cause and explain. And absolute nothingness contains no causes, no explanations, nothing that could produce something. And so the emergence from nothing seems impossible, seems to violate principles of causation and explanation. And yet here we are. Existence is actual. Something exists. And this existence seems inexplicable, seems to be a brute fact that cannot be explained in terms of anything more fundamental, because there is nothing more fundamental than existence itself. One response to the ontological paradox accepts it, accepts that existence is a brute fact, that there is no explanation for why there is something rather than nothing, that the universe just exists without reason. And this response abandons the principle of sufficient reason, abandons the demand that everything be explained, and treats existence as the foundation, as the starting point beyond which explanation cannot go. And this response is common among atheist philosophers, among those who see the universe as all there is, as existing without creator or external explanation. And the ontological paradox is dissolved by rejecting one of its premises, by denying that existence requires explanation. Another response appeals to necessary existence, argues that something must exist, that nothingness is not a genuine possibility, that existence is necessary, and the question why something rather than nothing is based on the false assumption that nothing is a real alternative. And various arguments have been offered for necessary existence, arguments that nothingness is unstable, that something must arise from nothing due to quantum fluctuations or logical necessity, or arguments that necessary beings like God exist by their nature and cannot fail to exist. And these arguments attempt to show that existence is not contingent, not dependent on external factors, but is necessary, is unavoidable. And if existence is necessary, then the question why something rather than nothing dissolves. The answer is that something must exist. Nothing is not an option. A third response questions the question, argues that why is there something rather than nothing is not a genuine question, is based on confusion about what questions can meaningfully be asked. And the question presupposes that nothing is the default, the expected state, and something is the deviation that requires explanation. But this presupposition is unjustified. There is no reason to privilege nothing over something, no reason to think nothing is more natural or more likely. And if something and nothing are on equal footing, then the question collapses, becomes unanswerable because it has no presupposition to support it. And the ontological paradox dissolves because the founding question is revealed to be pseudo-question. The ontological paradox also connects to debates about cosmology, about the origin of the universe, about whether the Big Bang was the beginning of everything, or whether something existed before, and cosmologists have proposed various scenarios. Eternal inflation, where universes are constantly being created in a multiverse. Cyclic cosmologies, where the universe goes through endless cycles of expansion and contraction. Quantum creation, where the universe emerged from quantum vacuum fluctuations, and each scenario pushes the question back, explains our universe in terms of something more fundamental. But the question remains why that more fundamental thing exists, why there is quantum vacuum, why there are laws of physics, why there is anything at all. And the ontological paradox persists at every level, cannot be escaped by postulating more fundamental entities or processes. Some philosophers embrace the paradox, treat it as revealing something deep about the limits of explanation, about the structure of understanding. That explanation must stop somewhere, must reach a foundation that is itself unexplained. And existence is that foundation, is the basic fact that grounds all other facts. And accepting this involves accepting that not everything can be explained, that the demand for total explanation is impossible to satisfy, and the ontological paradox is not a problem to solve, but a limit to accept, a recognition that human understanding has boundaries, that some questions have no answers, and the question, why is there something rather than nothing, is such a question, is beyond our capacity to answer. And we must live with the mystery, with the brute fact of existence. The universe exists, spreads across billions of light years, contains galaxies and stars and planets and life. And the question echoes, why? Why does any of this exist? Why is there something rather than nothing? And no answer fully satisfies, no explanation reaches the ultimate ground. And the ontological paradox persists, ancient and insoluble. A paradox that reveals the limits of metaphysics, the boundaries of explanation, the point where philosophy must fall silent and accept that existence simply is, without reason, without cause, without ultimate explanation. And the paradox endures as one of the deepest problems in philosophy, a problem that perhaps cannot be solved because it points to the edge of what can be understood, the limit where explanation gives out and brute fact takes over, and existence remains, mysterious and fundamental, and the question remains unanswered and perhaps unanswerable. The Monty Hall problem. A game show host presents 3 doors. Behind one is a valuable prize, a car perhaps, and behind the other 2 are less desirable outcomes, goats or some other consolation, and the contestant chooses a door, say, door number 1, but before the chosen door is opened, the host, who knows what is behind each door, opens one of the other doors, revealing a goat, and now 2 doors remain closed. The one the contestant originally chose, and one other, and the host offers a choice, stick with the original selection or switch to the other unopened door, and the question that has baffled and frustrated countless people is simple. Does it matter? Is there an advantage to switching? And the answer, counterintuitive as it seems, is yes. Switching doubles the probability of winning, changing the odds from 1 in 3 to 2 in 3. And this result violates most people's intuitions. Seems wrong? Feels like it cannot be right? Yet it is mathematically certain. And this is the Monty Hall problem, named after the host of the American television game show Let's Make a Deal, a puzzle, improbability that reveals how poorly human intuition handles conditional probability and how easily we can be misled by seemingly simple scenarios. The reasoning behind the correct answer goes as follows. When the contestant first chooses a door, the probability that the prize is behind that door is 1 in 3, and the probability that it is behind one of the other 2 doors is 2 in 3. And this much is uncontroversial. But when the host opens one of the other doors and reveals a goat, showing that the prize is not behind that door, the probabilities do not redistribute evenly among the remaining doors. The original choice still has a 1 in 3 probability of being correct because the host's action did not change the fact that the contestant's initial choice was made with 1 in 3 odds. But the other unopened door now has a 2 in 3 probability because the 2 in 3 chance that was distributed across the 2 unchosen doors is now concentrated in the single remaining door, and so switching to that door doubles the chance of winning. The intuition that misleads most people is the idea that once one door is opened and eliminated, there are 2 doors left, and the prize is equally likely to be behind either, giving a 50-50 chance regardless of whether you switch. But this reasoning ignores the information provided by the host's action, the fact that the host deliberately chose to open a door with a goat. And this deliberate choice is not random, it is constrained by knowledge. The host cannot open the door with the prize and will not open the door the contestant chose. And so the host's action provides information that updates the probabilities in a non-obvious way. A useful way to see why switching is advantageous is to imagine a version of the game with 1,000,000 doors. The contestant chooses one door, which has a 1 in a million chance of having the prize, and then the host opens 999,998 of the other doors, all showing goats, leaving only the contestant's original choice and one other door. And now it seems clear that the contestant's original choice, made with 1 in a million odds, is almost certainly wrong. And the remaining door, the one the host carefully avoided opening, is almost certainly the one with the prize, and switching gives a 999,999 in a million chance of winning. And the same principle applies with 3 doors, just with less dramatic numbers. The Monty Hall problem has been a source of controversy and heated debate, even among mathematicians and statisticians. And when Marilyn Vos Savant, a columnist known for her high IQ, published the correct answer in her magazine column in 1990, she received thousands of letters, many from PhD holders and professionals, insisting she was wrong. And the controversy revealed how deeply counterintuitive the solution is, how resistant people are to accepting it even when presented with mathematical proof. And this resistance reflects broader features of human cognition, the tendency to rely on heuristics and intuitions that work well in most everyday situations, but fail in probabilistic scenarios involving conditional information. The problem also illustrates the importance of conditioning in probability, the fact that probabilities must be updated in light of new information, and that the way information is acquired matters. The host's knowledge and deliberate choice of which door to open is crucial to the solution. If the host opened a door randomly and happened to reveal a goat, then the probabilities would indeed be 50-50. But because the host knows and deliberately avoids the prize door, the situation is different. And this distinction between random and informed selection is subtle and easy to miss. The Monty Hall problem has applications beyond game shows. It appears in medical testing, in legal reasoning, in machine learning, anywhere that probabilities must be updated based on partial information. And understanding the logic of the Monty Hall problem helps clarify how to reason correctly in these more consequential contexts, how to avoid fallacies, how to properly incorporate evidence into probability assessments. The problem also raises questions about the psychology of probability, about why people find certain probabilistic reasoning so difficult. And experiments have shown that even after being told the correct answer and shown simulations that demonstrate it, many people remain skeptical, unable to shake the intuition that switching makes no difference. And this persistence of false intuition, despite evidence, suggests that probabilistic thinking is not natural to humans, that we evolved in environments where simple heuristics like equiprobability were sufficient, and that the kind of careful conditional reasoning required by the Monty Hall problem is a learned skill that requires training and practice. The doors stand closed, one hides the prize, the host knows which. The contestant chooses. The host opens a door, reveals a goat, and offers the choice. And the decision, which seems inconsequential, which feels like a coin flip, is actually a test of probabilistic reasoning, a puzzle that most people get wrong, that defies intuition, that reveals the gap between how we think probability works and how it actually works. And the Monty Hall problem endures, a staple of probability courses, a cautionary tale about trusting intuition, a reminder that the world is full of situations where the obvious answer is wrong, where careful analysis reveals unexpected structure, where what seems like chance is actually determined by hidden information, and the contestant who switches, who overcomes intuition and follows the mathematics, walks away with the prize twice as often, and the contestant who sticks with the original choice, trusting gut instinct, wins only a third of the time. And the difference, the doubling of odds, is not a trick or a gimmick, but a genuine feature of how conditional probability operates, and the problem persists, puzzling new generations, frustrating those who encounter it, illuminating those who understand it. A small puzzle with large implications. A game show scenario that contains lessons about reasoning, evidence, and the limits of human intuition. The liar paradox. There exists a statement so simple that it collapses the foundations of truth itself. A sentence that devours its own meaning the moment it is spoken. And this is the liar paradox, a loop that has haunted logicians and philosophers for over 2,000 years. The paradox is most famously expressed in a single declaration: this statement is false, and the mind recoils at what follows. For if the statement is true, then it must be false as it claims. But if it is false, then it must be true because it correctly identifies itself as false. And so the cycle begins again, spiraling endlessly, without resolution, without escape. The ancient Greeks were the first to wrestle with this demon of language, and Epimenides, the Cretan, is often credited with an early version when he declared that all Cretans are liars, which implies that if he himself is a Cretan, then his statement must be a lie, which means Cretans might actually tell the truth, which means his statement might be true, which means it is false again, and the contradiction churns without mercy. Philosophers have spent centuries trying to solve or dissolve the paradox, and some argue that self-referential statements like this are simply meaningless, that language breaks down when it tries to refer to itself in this way, while others suggest that truth is not binary but exists on a spectrum, allowing for statements that are neither fully true nor fully false, hovering in some undefined space between. Bertrand Russell encountered similar contradictions when developing set theory and discovered that self-reference could destroy the entire logical framework of mathematics, leading him to create new systems that carefully excluded paradoxes like the liar from ever forming. The paradox also influenced Kurt Gödel, whose incompleteness theorems proved that within any sufficiently complex logical system, there will always be true statements that cannot be proven, which itself echoes the spirit of the liar paradox, the idea that truth and provability are not always the same thing. Some modern logicians have proposed paraconsistent logics, systems where contradictions can exist without causing the entire structure to collapse, allowing the liar paradox to be true and false simultaneously without forcing us to accept that everything is true, which would render logic useless. Others reject the paradox entirely, claiming that natural language is too vague and imprecise to support rigorous logical analysis, that the liar paradox is a quirk of grammar rather than a deep philosophical problem. Yet the paradox persists, refusing to die, surfacing in new forms, across disciplines, from computer science to legal theory, anywhere that self-reference appears. Consider a sign that reads, "Ignore this sign," or a rule that states there are no rules, or a person who says everything I say is a lie, and the same strange loop emerges, the same dizzying collapse of meaning. The liar paradox forces confrontation with the limits of language, logic, and truth itself, suggesting that reality may not always fit neatly into categories of true and false, that some truths may be inherently unstable, slipping through the fingers the moment they are grasped. It reminds us that words are not perfect mirrors of reality, but tools shaped by human thought. And sometimes those tools turn on themselves, revealing cracks in the structures we build to make sense of existence. The omniscience paradox. Can God know what it's like to not know everything? A theologian declares that God is omniscient, all-knowing, possessing complete and perfect knowledge of everything that can be known, every fact, every truth, every possibility, past, present, and future. And this claim seems straightforward, seems like a natural attribute of a perfect being, and yet a puzzle emerges when we consider what omniscience includes, whether it encompasses not just propositional knowledge, facts that can be stated as true or false, but also experiential knowledge, the knowledge of what something feels like, what it is like to undergo certain experiences. And the paradox asks whether God knows what it is like to not know something, whether God understands the experience of ignorance, confusion, discovery, learning, and if God does know what ignorance feels like, then God must have experienced ignorance. But if God has experienced ignorance, then God was not always omniscient, and if God cannot know what ignorance feels like, then there is something God does not know. And either way, omniscience seems incomplete, seems to have gaps, and this is the omniscience paradox, a puzzle about whether complete knowledge includes knowledge of incomplete knowledge, whether knowing everything includes knowing what it is like to not know. Imagine God trying to understand human experience, trying to grasp what it feels like to be confused, to search for answers, to wonder whether something is true, to make mistakes, to learn, to have that moment of insight when understanding suddenly clicks into place after struggling. And these experiences seem to require not knowing, seem to be essentially experiences of ignorance or partial knowledge. And if God has never been ignorant, has always known everything, then God has never had these experiences, has never felt what it is like to learn. And so there is an aspect of human experience that God cannot fully understand, cannot know from the inside, and this suggests that omniscience, defined as knowing everything, is actually impossible, because knowing everything includes knowing what it is like to not know everything, and these two forms of knowledge are incompatible, cannot both be had by the same being at the same time. The paradox connects to philosophical debates about the nature of knowledge, about whether there are different kinds of knowledge that cannot be reduced to each other, propositional knowledge, knowing that something is true, and experiential knowledge, knowing what something is like. And the distinction is illustrated by cases like colour perception. A person who has never seen red, but knows all the physical facts about red light, about wavelengths and retinal responses and neural processing, does not know what red looks like, does not have experiential knowledge of redness. And when they see red for the first time, they learn something new. And this suggests that experiential knowledge is distinct from propositional knowledge, cannot be obtained just by knowing facts. And if this is right, then God's omniscience, if it is purely propositional, misses something, misses the experiential dimension. And God does not know what it is like to see red for the first time, does not know what it is like to learn, does not know what ignorance feels like. Visualize the problem as a conflict between two divine attributes, omniscience, which requires always having known everything, and perfect empathy or understanding, which requires knowing what human experiences feel like from the inside. And human experiences include experiences of not knowing, and so perfect understanding seems to require having been ignorant. But omniscience seems to exclude ever being ignorant, and the two attributes pull in opposite directions, and something must give. Either God is not omniscient in the full experiential sense, or God does not fully understand human experience, or the distinction between propositional and experiential knowledge is mistaken, and God can know what ignorance feels like without ever being ignorant, through some superior form of knowledge that encompasses both facts and feelings. One theological response is to argue that God's knowledge is sui generis, is of a different kind than human knowledge, and God knows what ignorance is like, not by experiencing it, but by knowing its nature completely, by understanding all its causes and effects and phenomenal properties, and this understanding is so complete that it counts as knowing what ignorance is like, even though God has never been ignorant. And this response tries to bridge the gap between propositional and experiential knowledge, tries to say that sufficiently complete propositional knowledge includes experiential knowledge, but critics argue that this misses the point, that no amount of knowing facts about an experience captures what the experience is like, that there is an irreducible, subjective aspect that can only be known by having the experience, and so God's propositional knowledge, however complete, does not include experiential knowledge of ignorance. Another response is to embrace kenosis, the theological idea that God voluntarily limits divine attributes, and this view says that God can and does experience ignorance, that in becoming incarnate, in taking human form as Christ, God experienced human limitations, including not knowing things, and the gospel accounts support this, showing Jesus learning, growing in wisdom, not knowing when the end times would come. And this shows that God can experience ignorance without ceasing to be God, that omniscience is not essential to divinity, but is a power that can be set aside. And this resolves the paradox by denying that God is always omniscient, accepting that there are times when God voluntarily limits divine knowledge. But this creates new puzzles about whether a being that is not always omniscient can be called omniscient, and whether divine attributes can be temporary. A third response distinguishes between different kinds of ignorance, between merely not knowing a fact which God never experiences, and the phenomenology of searching for knowledge, the feeling of curiosity and discovery, which God might be able to simulate or understand through analogical reasoning, and God knows what it would be like to be in a state of ignorance, even though God is never actually in such a state. Just as someone who has never been to Mars might know what it would be like through detailed scientific knowledge and imagination, and this response tries to preserve both omniscience and experiential understanding by making experiential knowledge a form of imaginative or counterfactual knowledge. But again, critics argue that simulating or imagining an experience is not the same as having it, that there is a difference between knowing what it would be like and knowing what it is like. And God's simulated ignorance is not real ignorance and does not provide the experiential knowledge that the paradox concerns. The omniscience paradox also raises questions about divine immutability, the claim that God does not change, because if God learns or discovers anything, then God changes, gains knowledge that was previously lacking, and this violates immutability, and so perfect knowledge seems to require having always known everything, never learning, never being surprised, and yet this static, eternal knowledge seems incompatible with understanding temporal beings who do learn and are surprised, and reconciling omniscience and immutability with understanding human experience remains a challenge for classical theology. The paradox extends beyond ignorance to other experiential states. Does God know what it is like to be tempted, to feel desire for something forbidden, to struggle with moral choice? And if God is perfectly good, necessarily good, then God cannot be genuinely tempted, cannot feel the pull of evil, And so there is an aspect of human moral experience that God cannot know from the inside, and this creates distance between divine and human experience, suggests that God's understanding of humanity is necessarily incomplete, necessarily limited by God's perfection. And this is ironic, that God's perfection prevents complete understanding, that to fully know what it is like to be human, God would have to be imperfect, would have to experience weakness and ignorance and temptation, and these are incompatible with divine perfection. Some theologians embrace this limitation, argue that God's knowledge is perfect for a perfect being, but does not include the experiential knowledge of imperfection. And this is not a defect but a feature, a reflection of God's nature. And just as we do not think a perfect circle is defective because it is not a square, we should not think God is defective because God does not know what ignorance feels like, because such knowledge is incompatible with perfection. And the paradox assumes that all knowledge is good and more knowledge is always better. But perhaps some kinds of knowledge are only available through imperfection, and lacking them is not a limitation but a consequence of being perfect. Others reject omniscience entirely, argue that it is an incoherent concept, that complete knowledge is impossible, that there are always things that cannot be known, experiential states that require imperfection, future free choices that are not yet determined, logical truths that exceed any finite or infinite mind's capacity to grasp all at once. And if omniscience is impossible, then God is not omniscient. But this does not diminish God, does not make God less than perfect, because perfection means having all attributes that it is possible to have, not having impossible attributes. And omniscience, like omnipotence, when examined carefully, turns out to be impossible. And so God is not omniscient, but maximally knowledgeable, knows everything that can be known, and this is sufficient for divinity. God stands outside time, knowing all facts, all truths, all possibilities, and yet there is a gap, an experiential gap. God does not know what it feels like to search, to wonder, to be wrong, to learn. And whether this gap is a limitation or a feature remains contested, and the omniscience paradox persists, challenging the coherence of divine attributes, forcing clarification of what knowledge means, what kinds of knowledge exist, and whether complete knowledge is even possible. And the paradox remains unresolved, a permanent fixture in philosophy of religion, a reminder that even the most basic divine attributes, even the claim that God knows everything, conceal complexities and contradictions that philosophy continues to explore. The Noah paradox. There exists a peculiar sentence that seems to lead directly to contradiction, and this sentence states the knower is not known. And the question arises, is this sentence true or false? And both options lead to trouble, creating what is known as the Noah paradox, a puzzle in epistemic logic that reveals tensions between knowledge, truth, and self-reference. Suppose the sentence the knower is not known is true. Then by definition of what the sentence says, the fact that the knower is not known is itself not known. It is a truth that escapes knowledge. But if this is a truth, then it is knowable. There is nothing incoherent about knowing that something is not known. We know many facts of the form. Nobody knows X. We know that nobody knows the exact number of grains of sand on all the Earth's beaches, and so if the knower is not known is true, then someone could know it. But if someone knows it, then they know that the knower is not known, which means the knower, the fact that the knower is not known, is now known. And this contradicts the content of the sentence, which states that this fact is not known. And so assuming the sentence is true leads to contradiction. Suppose instead that the sentence is false, then its negation is true, which means the knower is known, which means someone knows that the knower is not known. But if someone knows this, then the knower, the proposition that the knower is not known, is indeed not known becomes known. And so the sentence is true after all. And again, contradiction emerges. And so neither assuming the sentence is true, nor assuming it is false, leads to a consistent outcome, and the paradox resists resolution through ordinary logical means. The Noah paradox is related to the liar paradox, and other self-referential semantic paradoxes. But it involves knowledge rather than truth, and it shows that knowledge, like truth, cannot be fully captured within a single, consistent formal system without restrictions. That self-reference combined with epistemic notions generates instability, and the paradox has implications for epistemic logic, the formal study of knowledge and belief, because standard epistemic logics treat knowledge as a modality, a sentential operator that applies to propositions. And these logics typically assume that knowledge is factive. If you know P, then P is true. And that knowledge is transparent. If you know P, then you know that you know P. And these principles, which seem innocuous, interact with self-reference to produce paradoxes like the knower. One response to the knower paradox is to restrict self-reference, to prohibit sentences that refer to their own knowability status, much like Tarski's hierarchy of languages prohibits sentences that refer to their own truth. And on this approach, the knower is not known is not a genuine sentence, not a proposition with a truth value, but a piece of ill-formed language that violates the rules of proper semantic construction. And while this response avoids contradiction, it does so at the cost of limiting what can be said, of ruling out sentences that seem grammatically and conceptually well-formed. And it leaves open the question of why these restrictions should be imposed, whether they reflect genuine features of knowledge or are merely technical devices to preserve consistency. Another response distinguishes between levels of knowledge, perhaps first-order knowledge about the world, second-order knowledge about knowledge, third-order knowledge about knowledge of knowledge, and so on, and argues that the knower paradox conflates these levels, that the knower is not known involves a sentence referring to its own knowability at the same level, and that this is illegitimate, that knowledge statements must be stratified into a hierarchy where knowledge at one level can only apply to propositions at lower levels, and this hierarchical approach mirrors solutions to the liar paradox and other semantic paradoxes, but it raises questions about whether ordinary knowledge attributions respect such hierarchies, whether in natural language we freely mix levels of knowledge without contradiction, and whether imposing hierarchies is a genuine solution or merely a way of avoiding the problem. Some philosophers embrace paraconsistent logic, systems that allow contradictions to exist without trivializing the entire system, without forcing the conclusion that everything is true. And in paraconsistent frameworks, the knower paradox can be true and false simultaneously. The sentence can be both known and not known, and the contradiction is tolerated rather than resolved, contained within the logical system without spreading. And while this approach is radical, it has the advantage of taking the paradox at face value, of not dismissing it as ill-formed or illegitimate, but recognizing it as revealing something genuine about the limits of consistent reasoning about knowledge. The knower paradox also connects to issues about the closure of knowledge under known entailment. The principle that if you know P and you know that P entails Q, then you know Q, because this principle, combined with the factivity of knowledge and certain assumptions about self-knowledge, can be used to derive paradoxes, and some epistemologists have questioned whether closure should be unrestricted, whether there are cases where you know P and know that P entails Q but do not know Q, perhaps because Q is a complicated consequence that you have not worked out, or because Q involves self-referential or paradoxical content that resists knowledge. The paradox raises questions about the transparency of knowledge, the principle that if you know P then you know that you know P, because this principle, known as the KK principle, is controversial. Some argue that it is too strong, that there are cases where you know something without knowing that you know it, perhaps because you're not introspectively aware of your knowledge, or because the recognition of knowledge requires second-order reflection that you have not performed. And if the KK principle is rejected, then some versions of the knower paradox may be blocked because the reasoning depends on assumptions about what is knowable given what is known. The knower paradox sits alongside other epistemic paradoxes, the surprise examination paradox, Fitch's paradox, Moore's paradox, each revealing different tensions in our concepts of knowledge and belief, each challenging the assumption that these concepts can be fully formalized without residue, and together they suggest that knowledge is a more complex and less tractable notion than it appears, that self-reference and knowledge do not mix well, that there are limits to what can be known or consistently said about knowledge, and that the project of epistemic logic, while valuable, must navigate carefully around paradoxes that threaten its foundations. The sentence "the knower is not known" hangs in conceptual space, neither comfortably true nor comfortably false, a knot that logic cannot untie, a puzzle that resists the tools we use to solve puzzles, and it reminds us that language and thought contain traps, that self-reference is dangerous, that some sentences generate contradictions not because they are meaningless, but because they expose the limits of our logical systems, the boundaries where consistency breaks down and paradox takes over, and the knower paradox remains, a thorn in the side of epistemic logic, a challenge to anyone who claims to understand what knowledge is and how it operates. And the question persists, is the knower known or unknown? And the answer, whatever it is, leads to contradiction, and the paradox endures, unresolved and perhaps unresolvable, a permanent fixture in the landscape of philosophical puzzles, a reminder that even knowledge itself, the concept at the heart of epistemology, contains mysteries that philosophy has not yet fathomed. The growing argument, objects change size over time. A child grows into an adult, a sapling becomes a tree, a pebble is worn smooth by erosion, and yet we say these are the same entities, the same person, the same tree, the same stone. But if size and shape change, can identity truly remain? And this is the growing argument, sometimes called the growing block paradox, or the problem of material constitution. A puzzle about how objects can gain or lose parts while remaining numerically identical to themselves. Consider a statue made of clay, and a sculptor adds more clay to it, making it larger, and then removes some clay, making it smaller, and at each moment the statue is made of different material, occupying a different volume, and yet we call it the same statue throughout the process. But if the statue is identical to the lump of clay that constitutes it, then the statue and the clay should share all their properties. Yet the statue has properties the clay does not. The statue has aesthetic value. The statue was created at a certain time. The statue could survive minor alterations, while the clay, as a mere lump, has none of these properties. And so the statue and the clay cannot be identical, even though they occupy the same space and are made of the same material. The paradox deepens when we consider the career of the clay. The lump existed before the statue was formed, and will exist after the statue is destroyed, and so the lump and the statue have different temporal boundaries. They begin and end at different times, and if they are not identical, then there must be two objects occupying the same space at the same time, the lump and the statue. And this seems strange, an unnecessary multiplication of entities. Some philosophers embrace this conclusion, arguing that the world contains far more objects than we ordinarily recognize, that every statue is accompanied by a lump, every organism by a mass of cells, every table by a quantity of wood, and that identity is highly context-sensitive, determined by how we carve up the world conceptually, rather than by objective metaphysical facts. Others reject this view, arguing that the statue and the lump are the same object considered under different descriptions, that the properties that seem different are not intrinsic properties, but extrinsic or relational ones, that being a statue is a matter of how the lump is shaped and how it is regarded rather than being a separate object. The growing argument also applies to living organisms, because a person gains and loses atoms constantly. The body grows from infancy to adulthood, shrinks in old age, yet personal identity persists. And the question arises whether the person is identical to the collection of matter that makes up their body at any given moment? And if not, then what are they? And if so, then how can they survive the replacement of that matter over time? Mereology, the study of parts and wholes, offers various theories to address these puzzles. Some argue that objects are identical if they share all the same parts at the same time, while others allow for gradual replacement, saying that identity can be maintained as long as the changes are continuous and not too drastic. And still others embrace temporal parts, arguing that objects are four-dimensional, with different temporal slices, and that the question of identity over time is really a question of whether those slices are connected in the right way. The growing argument forces confrontation with the question of what objects are, whether they are material lumps, patterns, processes, or conventional designations, whether identity is absolute or relative, whether the world contains discrete, persistent entities or only a flux of matter temporarily arranged in stable configurations, and whether our language and concepts, which treat objects as enduring individuals, accurately reflect the structure of reality or impose a simplifying grid on something far more fluid and complex. The paradox remains unresolved, a source of ongoing debate in metaphysics, and it reminds us that growth and change, the most ordinary features of existence, conceal profound mysteries about identity, persistence, and the nature of the things that populate our world. The homunculus problem, the little person inside who watches the brain. A neuroscientist explains vision by saying that light enters the eye, forms an image on the retina, signals travel through the optic nerve to the visual cortex, and there an image is formed, a representation of the external scene. And this explanation seems to explain something, seems to describe how vision works. But philosopher Daniel Dennett points out a fatal flaw. The explanation assumes that someone or something views the image in the visual cortex, reads the representation, sees what is represented, and this viewer is like a little person inside the head, a homunculus watching an internal screen. And now we need to explain how the homunculus sees, how it processes the image, and the same problem arises. We imagine the homunculus has its own eyes and brain, its own visual cortex with another image, and another homunculus inside the homunculus viewing that image, and the regress continues infinitely. Homunculi all the way down, each one requiring its own internal viewer, and nothing is actually explained. The mystery of perception is just pushed back one level, relocated from the person to the homunculus. And this is the homunculus problem, the fallacy of explaining mental processes by positing an internal agent that performs those processes. And the problem reveals that explanation requires mechanism, requires showing how processes work without assuming an intelligent agent that does them, requires decomposing tasks into simpler tasks that eventually reach mechanical operations that require no intelligence, no awareness, no homunculus. Imagine opening a person's skull and looking at the brain, and there you find a tiny theatre, a little stage where sensory information is displayed, sounds and sights and sensations. And sitting in the audience is a little person, the homunculus watching the show, perceiving the displays, making decisions, sending commands. And this little person is you, is the conscious self, the experiencer. And this picture is intuitively appealing, matches how consciousness feels like there is someone inside watching experience. But the picture is incoherent, because now we must explain how the homunculus perceives, how it watches the theatre. And if we say it has its own brain, its own sensory organs, then we need another homunculus inside the first one, and the regress is infinite, and nothing is explained. And the homunculus picture must be abandoned, must be replaced with explanations that do not posit internal observers, that explain perception and consciousness in terms of processes that are themselves mechanical, that do not presuppose the intelligence or awareness we are trying to explain. The homunculus problem arises repeatedly in theories of mind, in explanations of perception, cognition, action, and consciousness, because it is tempting to explain mental processes by saying that some part of the mind does something, recognizes patterns, interprets symbols, makes decisions, and implicitly we imagine this part as an intelligent agent, as a little homunculus with its own capacities, but this merely relocates the problem, does not solve it, and genuine explanation requires decomposing intelligent processes into non-intelligent mechanisms, showing how intelligence emerges from non-intelligent parts, how mind arises from matter that is not itself minded. Visualize the solution to the homunculus problem as building intelligence from the bottom up, starting with simple, mechanical processes that require no intelligence, reflexes, stimulus-response pairs, basic computations, and combining these processes into more complex systems, and these systems into still more complex systems. And through hierarchical organization, through layers of increasing complexity, intelligent behavior emerges without any layer requiring an internal intelligence, without any homunculus. And this is how cognitive science and neuroscience proceed, explain perception, not as viewing internal images, but as processing information through stages, each stage performing simple transformations, and consciousness emerges from the whole process, from the organization of these transformations, not from any single component that views or experiences or decides. Dennett's solution to the homunculus problem involves discharging homunculi, replacing each intelligent homunculus with stupider homunculi, with less capable agents that perform smaller tasks, and replacing those with even stupider agents, until finally we reach agents so stupid they can be replaced by mechanical processes, by circuits, by neurons, and the entire system operates without any component that requires intelligence, and yet the system as a whole exhibits intelligence, exhibits mind. And this shows that intelligence is not a basic property that some things have, but an emergent property that arises from complex organization of simple parts. And minds are not mysterious entities, but are patterns of activity in brains, patterns that can be explained without remainder in terms of physical processes. The homunculus problem also appears in discussions of free will and agency, where we imagine a self, a decision maker, an agent inside who chooses what to do, and this self is another homunculus, is an unexplained explainer, a source of choice whose own choices are not explained. And genuine explanation of action requires showing how decisions arise from brain processes, how choices emerge from neural activity without positing an agent whose choices are uncaused or caused by nothing, and this requires abandoning the homunculus picture of self, replacing it with a distributed picture where the self is not a little person inside but is the whole system, is the pattern of activity across the brain, and agency emerges from this pattern. One response to the homunculus problem accepts it as showing that certain kinds of explanation are illegitimate, are pseudo-explanations that do not actually explain, and cognitive science must avoid homunculi, must explain processes mechanically, must show how mind arises from mindless matter, and this constraint shapes the development of theories to be mechanistic, to specify algorithms, to avoid appeals to mysterious inner agents. Another response questions whether the homunculus is always fallacious, argues that sometimes positing subagents, components with limited intelligence, is a useful step in explanation, as long as these subagents are eventually explained themselves, as long as the regress terminates. And this is Dennett's discharge strategy: use homunculi temporarily as placeholders, as ways of structuring explanation, but always with the goal of replacing them with mechanical processes. And so homunculi are tools for thought, are scaffolding that is removed once the real explanation is built. A third response argues that the homunculus problem reveals limits of reductionist explanation, suggests that consciousness might resist explanation in mechanical terms, might require a different approach, and the persistent intuition that there is someone inside, an experiencer, a subject, might reflect something genuine about consciousness that cannot be captured by functional or mechanical accounts. And this response is sympathetic to dualism, to the view that consciousness is not reducible to physical processes, that the subjective character of experience is not explicable in terms of objective mechanisms. The homunculus problem also connects to debates about consciousness and the hard problem, because part of what makes consciousness seem mysterious, seem hard to explain, is the intuition that consciousness involves an experiencer, a subject who has experiences, and this experiencer is like a homunculus, is an unexplained element in explanations of consciousness. And if we try to explain consciousness by saying brain processes produce experiences for a subject, then we have not explained consciousness, but only relocated the mystery to the subject. And so explaining consciousness requires eliminating the homunculus, showing how subjective experience arises without presupposing a subject who has experiences, showing how there can be experiences without an experiencer, or how the experiencer is itself constituted by the experiences rather than being prior to them. The little person sits inside the brain, watching the neural theatre, and the philosopher points out the infinite regress, the explanatory failure, and the homunculus must be eliminated, must be replaced by mechanisms, by processes that are themselves mindless, but collectively produce mind. And the homunculus problem persists as a methodological constraint on cognitive science, a warning against pseudo-explanations, a requirement that theories genuinely explain rather than merely labeling or relocating mysteries. And the problem remains relevant, remains invoked whenever theories implicitly appeal to internal agents, to components with unexplained intelligence, to parts that do what needs explaining, and the homunculus is a perennial temptation, a fallacy that resurfaces in new forms, and vigilance is required to avoid it, to ensure that explanations of mind explain all the way down to mechanical processes, to neural activity, to physical causation, and the little person must vanish, must be dissolved into the processes that were supposed to serve it, and the brain emerges not as a theatre with an audience, but as a complex system of interacting components, none intelligent on its own, but collectively generating the intelligence we attribute to the person. And the homunculus problem endures as a permanent challenge to theories of mind, a reminder that genuine explanation requires mechanism, requires discharge of intelligence into non-intelligent processes, and the little person inside is a fiction, a conceptual error. An understanding mind requires abandoning this fiction, embracing the mechanistic view that minds are what brains do, and homunculi are explanatory dead ends that must be avoided. The frozen time paradox. Time flows, or so it seems, carrying events from past to present to future in an unbroken stream. Yet what if time could stop? What if every process in the universe froze for a moment, or an hour, or 1,000 years, and then resumed exactly as it was? Would anyone notice? Could anyone notice? And this is the frozen time paradox, a thought experiment that questions whether time itself is observable, or whether it is merely an ordering of events, invisible and perhaps illusory. Imagine that at this very moment time stops, every atom ceases to move, every thought halts mid-formation, every photon hangs suspended in space, the entire universe frozen in a perfect still image. And this frozen state persists for an arbitrary duration, perhaps 1 billion years, and then suddenly time resumes, and everything continues exactly as it was. And the question arises, did anything happen during that frozen interval? Did time pass? And if no change occurred, can it be said that any time elapsed at all? The paradox strikes at the relationship between time and change, suggesting that time without change is meaningless or undetectable, that the passage of time is defined by the occurrence of events, and that if nothing changes, then nothing distinguishes one moment from another, and so the frozen interval, no matter how long, is equivalent to no interval at all. Aristotle grappled with this issue, arguing that time is the measure of change, that time does not exist independently of the processes it measures, and that without motion or change there can be no time. And this view suggests that the frozen time scenario is not a case of time continuing without change, but rather a case of time ceasing to exist during the frozen period. Others, particularly those who embrace the block universe view, argue that time is an independent dimension of space-time, that it exists whether or not anything changes within it, that the frozen interval would be a real extension of time, even if no events occurred within it. Though this raises the question of how such an interval could ever be detected or have any physical meaning. The paradox also touches on the nature of consciousness and subjective experience, because if time froze and then resumed, no conscious being would remember the frozen period, no measurement device would register it, no physical process would show evidence that it occurred, and so in what sense did it happen? And if it leaves no trace, can it be said to have any reality at all? Some philosophers draw a distinction between time as a parameter in physical equations, a variable that describes when things happen, and time as it is experienced, the feeling of duration and flow. And they suggest that the frozen time paradox exposes a gap between these two concepts, that mathematical time might continue during a frozen interval, but experiential time would not. The paradox connects to debates about the reality of time, whether time is fundamental or emergent, whether it is a feature of the universe or a feature of how we perceive the universe, and whether the flow of time, the sense that the present moment is moving forward, is an objective fact or a subjective illusion created by consciousness. Quantum mechanics adds another layer to the puzzle, because at the quantum level, the concept of time becomes strange. Entangled states do not evolve smoothly, but exist in superposition until measured, and some interpretations suggest that time emerges from quantum correlations rather than being a fundamental aspect of reality. The frozen time paradox forces confrontation with the question of what time is, whether it is possible for time to exist without change, whether duration has meaning in the absence of events, and whether the universe could be paused and unpaused without anyone ever knowing, without any physical consequence, and if such a scenario is indistinguishable from time continuing normally, then perhaps the question itself is meaningless, a pseudo-problem that arises from thinking about time as if it were a substance that flows rather than a dimension that orders. And yet the intuition remains that time is real, that it passes, that moments follow one another, and the paradox lingers as a reminder that even this most basic aspect of existence, the passage of time, is far from fully understood. The paradox of confirmation. Why seeing a red apple proves all ravens are black. A scientist seeks to confirm the hypothesis that all ravens are black, and the obvious way to test this hypothesis is to observe ravens, to find ravens and check their colour. And each black raven found provides evidence for the hypothesis, confirms it slightly, makes it more likely to be true. And this seems straightforward, seems like basic scientific method. Observe instances that match the hypothesis and they provide confirmation. But philosopher Carl Hempel noticed something strange, something that reveals how confirmation works in unexpected ways. And the strangeness begins with a logical equivalence. The statement, "all ravens are black," is logically equivalent to the statement, "all non-black things are non-ravens." These two statements have exactly the same truth conditions. If one is true, then the other must be true. If one is false, then the other must be false. And so anything that confirms one statement should confirm the other, should provide equal evidence for both. But now consider what confirms the statement. All non-black things are non-ravens, and observing a non-black non-raven should confirm it. Observing a red apple provides evidence that all non-black things are non-ravens because a red apple is non-black and is a non-raven. And since all non-black things are non-ravens is equivalent to all ravens are black, observing a red apple should confirm that all ravens are black. And this seems absurd. Seems like observing apples in your kitchen has nothing to do with the colour of ravens. And yet the logic is impeccable. And this is the paradox of confirmation, also called Hempel's paradox or the Raven paradox. A puzzle about how evidence works, about what confirms scientific hypotheses, and about whether our intuitions about confirmation can be trusted. Imagine a scientist sitting in a laboratory surrounded by red apples, carefully noting each one, recording that it is red and not a raven, and claiming that this investigation provides evidence about ravens, evidence that all ravens are black. And this seems ridiculous. Seems like the scientist has confused what is relevant to the hypothesis, has mistaken irrelevant observations for genuine evidence, and yet the logical structure is clear. Each red apple confirms that all non-black things are non-ravens, and this statement is logically equivalent to all ravens are black. And confirmation should be closed under logical equivalence. If observation O confirms hypothesis H, and H is equivalent to H, then O should confirm H out, otherwise confirmation would depend on how we phrase hypotheses rather than on what they say. And so the scientist with the red apples is doing legitimate science, is confirming a hypothesis about ravens even though no ravens are involved. And the paradox forces us to either accept this counterintuitive conclusion or reject some principle we thought was obvious about how confirmation works. The paradox reveals tension between formal logic and intuitive judgment. Because formally the argument is valid, red apples do confirm that all ravens are black through the equivalence with all non-black things are non-ravens, but intuitively this seems wrong. Seems like red apples are irrelevant to ravens, and resolving this tension requires either explaining why the formal conclusion is actually correct and our intuitions are misleading, or showing where the formal argument goes wrong, where a principle we thought was valid actually fails. And both options have been pursued, have generated extensive philosophical literature, have produced multiple proposed solutions, none of which has won universal acceptance. Visualize the logical space of all objects, divided into 4 categories: black ravens, which confirm the hypothesis directly; non-black ravens, which would falsify the hypothesis; black non-ravens like coal or blackboards, which seem irrelevant; and non-black non-ravens like red apples, which also seem irrelevant. And the paradox says that observing objects in the 4th category, non-black non-ravens, provides evidence for the hypothesis that all ravens are black, because these observations confirm the equivalent hypothesis that all non-black things are non-ravens, and each red apple, each green leaf, each blue car provides a tiny bit of evidence that ravens are black. And while this sounds absurd, it follows from principles of confirmation that seem undeniable. One proposed solution appeals to background knowledge and prior probabilities, argues that red apples do confirm that all ravens are black, but the confirmation is so tiny as to be practically negligible. Because we have vast background knowledge about the number of non-black things in the universe, we know there are billions and billions of non-black objects, and observing one red apple increases our confidence that all non-black things are non-ravens by an infinitesimal amount, whereas we have much less background knowledge about ravens, and observing one black raven increases our confidence that all ravens are black by a larger amount. And so both observations provide confirmation, but in vastly different degrees. And this explains why it seems pointless to observe red apples when investigating raven colour. Not because they provide no confirmation, but because they provide so little confirmation that the exercise is worthless. And this Bayesian solution preserves the formal logic while explaining the intuition, accepts that red apples confirm the hypothesis, but explains why we correctly ignore them. Another solution challenges the equivalence condition, argues that confirmation is not closed under logical equivalence, that logically equivalent statements can receive different confirmation from the same observation. And the reason is that confirmation depends not just on logical form, but on the way hypotheses are stated, on which predicates are used, on how the hypothesis carves up the world, and all ravens are black, and all non-black things are non-ravens, while logically equivalent organise the world differently, make different predicates primary, and observations confirm hypotheses relative to these organisations, and a black raven confirms the first hypothesis more than the second, and a red apple confirms the second more than the first, even though they are equivalent. And this solution rejects the principle that equivalent hypotheses must receive equal confirmation from the same observation. A third solution appeals to selective confirmation, argues that observing a red apple provides some evidence for all ravens are black, but only under certain conditions, only when the observation is made in a context where it has the potential to falsify the hypothesis, and seeing a red apple in your kitchen where you never expected to find a raven provides no confirmation, provides no new information, but seeing a red apple in a context where you might have found a non-black raven, where the observation had the potential to reveal a counterexample, does provide confirmation. And so confirmation depends not just on what is observed, but on the circumstances of observation, on what was at stake, on what alternatives were possible. And this solution ties confirmation to potential falsification, treats confirmation as depending on whether observations eliminate possibilities rather than merely matching hypotheses. The paradox also connects to the problem of induction, to Hume's problem of how we can justify inferring from observed instances to unobserved cases, because confirming all ravens are black by observing black ravens assumes that the future will resemble the past, that unobserved ravens will be like observed ravens, and this assumption itself cannot be justified without circularity. And the paradox adds another layer, shows that even if we accept induction, we face puzzles about what counts as confirming evidence, about whether observations of non-ravens can tell us about ravens, and these puzzles reveal that confirmation is more complex than it appears, cannot be reduced to simple pattern matching or accumulation of positive instances. The scientist with the red apples continues recording, carefully noting each observation, and the paradox hangs over the investigation, a question about whether this absurd procedure is actually legitimate science, whether red apples really do provide evidence about ravens, and the answer depends on how we understand confirmation, on which principles we accept, on whether we follow formal logic or intuitive judgment, and the paradox remains unresolved in the sense that different solutions appeal to different intuitions, make different trade-offs, and no consensus has emerged, only a recognition that confirmation is subtle, that evidence works in non-obvious ways, that formal principles can lead to counterintuitive conclusions, and that the relationship between observation and theory, between data and hypothesis, between evidence and confirmation, is more complex than common sense suggests, and Hempel's paradox endures as a classic problem in philosophy of science, a puzzle that continues to challenge our understanding of scientific method, a reminder that even basic concepts like confirmation and evidence conceal difficulties that philosophy has not fully resolved.